6.3, simplifying complex fractions. So complex fractions, you're going to see them everywhere in math. This is not the first time we'll see it. Oh my gosh, like, they just come everywhere. They come out everywhere in multiple places. So let's start getting comfortable with them now. Let's start learning how to work with them. All right. This is technically division. Fractions are just division. So this bar right there, that little bar, just means division. So what's on top goes to the left, what's on bottom goes to the right. It goes in order. Top is first, bottom is second. So we'll have 10 over 3x divided by, wrong color, sorry, divided by 5 over 6x. And again, that little division symbol, it came from the fraction bar. So this is where we do something. It's called keep, change, flip. You have probably heard that before. So what we do is we keep the first one exactly the way it is. We change the sign to multiplication. And we flip the second one. So the second one will become 6x over 5. Cool, right? All right, now we can simplify this. So why are we doing all this? You cannot divide fractions. You can't divide division. I know, right? That sounds weird. It's because a fraction is division. So you cannot divide division. You have to multiply. So we're multiplying. That's why we keep, change, flip. All right. There's two ways that we can do this. One way. So there's two ways that we can do this. One of the ways is to multiply straight across. So I'm actually going to show you both ways here. So one way is to multiply straight across. So we'll have 60x over 15x. And then we simplify. So x cancel, and then 60 divided by 15 is 4. So that's one way to do that. Another way is to do something called cross multiplication. So cross multiplication is where we look diagonally to see if there's anything that they may have in common. So let's see. 10 and 5, they have 5 in common. So 10 divided by 5 is 2, and 5 divided by 5 is 1. Now we look the other way. So the other way, they both have an x, so that cancels. And then 6 and 3 have 3 in common. So 6 divided by 3 is 2. 3 divided by 3 is 1. So I'm just going to write what we have left over. We have 2 over 1 times 2 over 1, which is just 4. So you see how we get the same answer. It just depends on how you want to do it. It's totally up to you. I'm going to cross multiply. I like to cross multiply. It's something that we should just get used to. So if you are a science, technology, engineering, or math major, get used to cross multiplying. It's just easier that way. If you are going to like statistics and stuff like that, do it however you want. It won't pay off in the end if you know how to cross multiply. You have to know how to work with fractions. There's no going around that. But cross multiplying, it's not going to be super beneficial for statistics, but for college algebra, for trigonometry, for pre-calc, for calculus, cross multiplying is super beneficial. Makes things easier. Okie dokie, moving on. So we have x over x plus 2 all over x squared over x plus 2. So do you notice something? The denominators are the same. So the denominator on the top is the same as the denominator on the bottom. If that's the case, they cancel out. But what if, you can't remember that? I'll teach you another way. But if you do remember that, they do cancel. So I'm going to write what we have left over. What we have left over is x over x squared I can take, they both have x in common, so if I take x out of x, I'm left with 1. If I take x out of x squared, I'm just left with x. So my final answer is 1 over x. But what if we forget the rule? What if we forget that little trick I taught you? That's fine. I'll rewrite the problem. I'll show you another way to think about this. So we have x over x plus 2 all over x squared over x plus 2. So we keep, change, flip. So we keep the first one. We have so we have x over x plus 2 divided by x squared over x plus 2. Let's keep, change, flip. So we keep the first one, we change the sign, and we flip the second one. So we can cross multiply, or if you want to multiply straight across, you'll still get the same answer, but I'm going to cross multiply. So diagonally, they're both x plus 2. Since they're both x plus 2, they cancel. And then this way, they both share an x. So x divided by x is 1. X divided by x squared is just x. So what we're left with is 1 over nothing. So 1 over nothing is just 1 times 1 over x. So we have 1 over x is our answer. See, get the same answer. It's just however you want to do it, however you feel comfortable with. It's all good. All right. We have x squared minus 9y over xy all over 1 minus y minus 3 over x. All right, things are getting a little weird here. That's okay. Let's just treat it the same way. So first thing we do is we recognize that this is division. Since we recognize that, we can go ahead and make this look just less intimidating, more normal, I guess. So we change that little sign to division, because that's all a fraction is division. All right, so since we have a bunch of stuff going on, let's go ahead and just wrap these with parentheses just to be careful. Anytime we just have a lot going on, just wrap it. Just wrap it. Okay. So I want to break this down. I want to see if I can simplify anything. So here on top, can I simplify anything? I totally can, because they have something in common. Well, not it's not something they have in common, but it's a difference of squares. Excuse me. So it's a difference of squares. So we have x minus 3y and then x plus 3y. So we factored that. And that's all over xy. And then here, it's telling us to subtract. So I'm going to do that. It's telling us to subtract. So let's do that. I'm going to bring this out. This right here, I'm going to bring it out and work with it. So we have 1 over y minus 3 over x. So we need the common denominator. So our common denominator, we just multiply them together, y times x, so yx. So this is missing a y, and this is missing an x. We're going to multiply. So we have x over xy minus 3y over xy. Let's combine. So when we combine, we have x minus 3y over xy. So that's what we can switch this to. We can switch it to x minus 3y over xy. If it's telling you to add or subtract, if it's telling you to do some type of operation, you have to do it, because that's part of simplifying. Now we can keep, change, flip. So we keep the first one as is. We have x minus 3y, x plus 3y, and that's over xy. We change the sign in the middle to multiplication. And we flip the second one. So xy over x minus 3y. So let's look diagonally to see if we can cancel anything. So here we can cancel out xy. They're identical. Then if we look the other way, we have x minus 3y, x minus 3y. So this whole thing gets canceled out. All we are left with, writing everything we're left with, we are only left with x plus 3y. You can put parentheses, no parentheses, it's up to you. All right. Next complex fraction. So we have 4 over 5 minus x plus 5 over x minus 5 all over 2 over x plus 3 over x minus 5. So we're going to take this piece by piece because we have a lot of stuff going on. So I'm only going to right now just look at focus and look at the top. So I'm going to bring it out. We have 4 over 5 minus x plus 5 over x minus 5. So I need to add these because that's what it's telling me to do. In order to add them, I need to find the common denominator. So remember, see how the bottoms look the same? They do, right? Except they're just swapped. Remember, whenever that is the case, the common denominator is negative, and then whatever the term, like the normal looking term is. So we can go ahead and switch this because we know what it stands for. We know that it actually is negative x minus 5. I'll show you just in case how I got to there. So we have 5 minus x. Move it around. We have negative x plus 5. Take the negative out. There we go. That's how I got to that. And then we're going to add that to 5 over x minus 5. So the only thing, so if we look at the first one, it is the common denominator. The second one is only missing the negative, so I just have to put a negative on each. So we have 4 over negative x minus 5 plus negative 5 over negative x minus 5. So we could do 4 minus 5, that's negative 1 over negative x minus 5. So that's what the top comes to. The top here, the top circled in green, it comes to negative 1 over negative x times x minus 5. Okay, so that's what the top is. Now let's do the bottom. So let's do the bottom. Let's simplify that. So this is the bottom. Let me write that. Top and then bottom. All right, so the bottom we have 2 over x plus 3 over x minus 5. All right, so we have to add these because it's telling us to add them. So what we're going to do is find the common denominator. So the common denominator, just multiply them together. We have x minus 5. So from the left one, it's missing x minus 5. On the right one, it's missing x. So on top, we're going to distribute the 2. So we have 2x minus 10 over our denominator. And that's plus, we're going to multiply 3 times x. So 3x over x minus 5. Now that they have the same denominators, we can go ahead and add the tops. So that's a positive 3x. So we'll have 2x minus 10 plus 3x over x minus 5, combine like terms, and we get 5x minus 10 over x minus 5. And you're like, well, what about the 5 on top? Don't worry about it. You don't have to take it out. Boom, done. We simplified it. The reason why you're probably asking, like, why don't we take it out? Because if I show you, if we do that, can I cancel anything? I can't cancel anything. That's why I don't do that. All right, so the bottom equals 5x minus 10 over x times x minus 5. So let's rewrite that where it's supposed to go. So on top, the top simplified, the top right here, The top simplified to negative 1 over negative times x minus 5. And then the bottom, this bottom right here, simplified to 5x minus 10 over x times x minus 5. Now that we did that, we can keep change flip, or if you see it, you see it. That x minus 5, yes, you can cancel that out. You can. That x minus 5 can be canceled. I'm not going to do it that way for this video, but if you see it, yep, you can do it. All right, so what I want you to do, if you don't see that, that's fine. We keep change flip. But before we do that, we know that this right here, that just means division. So we have negative 1 over negative times x minus 5 divided by 5x minus 10 over x times x minus 5. We keep change flip, so keep the first one. Change the sign, flip the second one. Alright, let's cancel out diagonally. So if we look this way, they have nothing in common. If we look this way, they have x minus 5 in common. Do you see anything else? Do you see anything else? What about the two negatives? Don't they create positives? They do. If you didn't see it, you would see it at the end. It's okay. So let's write we have left over. On this side, we have nothing. We just have 1. We don't have to write 1. So we have nothing left on the left side. On the right side, we're left with x over 5x minus 10. And that's... How do we know if we're done? How do we know if that's it? Top. Can we factor anything on top? Nope. Can we factor anything on the bottom? We can. So we can factor the bottom. Now we factor the bottom. Now we have our final answer. So how do you know you're done? Ask yourself, look at the top. Can I factor? Nope. Bottom. Can I factor? Yes or no? It just depends, okay? All right. Moving on. All right, we're going to separate them. So we have x plus 3 over x squared minus 9. Let's simplify. We can factor. So on top, we have x plus 3. On the bottom, we have x minus 3, x plus 3. And we can simplify. We can, because x plus 3, x plus 3. So on the top, we're left with 1. I'm sorry, that happens sometimes. On the top, we're left with 1, and on the bottom, we're left with x minus 3. So the top simplifies to 1 over x minus 3. All right, let's talk about the bottom now. So the bottom we have, since we have fractions, let's do 1 over 1 plus 1 over x minus 3. All right, it's telling us to add. So we have to add these. That means we have to get our common denominator. So our denominator, we're just going to multiply them together. So 1 times x minus 3, that's just x minus 3. So this is already x minus 3. That means the left side needs x minus 3. So we now have x minus 3 over x minus 3 plus 1 over x minus 3. Alright, on top we don't need the parentheses anymore because there's nothing more to simplify, so we can pretend that they're not there. So we have x minus 3 plus 1 over x minus 3, combine like terms. And when we do, we get x minus 2 over x minus 3. Let's wrap our factors. So the bottom simplified to x minus 2 over x minus 3. Now let's write this where it's supposed to go. So the top simplified, this top right here, simplified to 1 over x minus 3. And that's being divided by the bottom. So the bottom simplified down into x minus 2, x minus 3. Yes, you can cancel x minus 3. You can cancel those out. But let's say you don't see that. We know that this symbol right here just means division. So we're going to switch the way this looks. So we switched the way it looked. And now let's look diagonally. So here, they have nothing in common. Here, my bad. Let's see what they have. Let's keep change flip. So we keep the first one. We change the sign. We flip the second one. Diagonally, so here they have nothing in common. Here they have x minus 3 in common. So what we have left is 1 over x minus 2. All right, let's take these apart. So the top, is telling us to add, so we're going to add. So our denominator, just multiply them together, is x plus 2, x plus 7. So here we're missing x plus 7. And on the right, we're missing x plus 2. So on top, we have 2 times x plus 7 over our denominator. Then we have plus 6 times x plus 2 over our denominator. Let's distribute. When we distribute, we get 2x plus 14 over our denominator, and we're going to distribute the 6 to 6x plus 12 over our denominator. Now that they have the same top, let's combine like terms. So we have 2x plus 14 plus 6x plus 12 over our denominator. Combine like terms, so 2x and 6x is 8x. 14 and 12, that's 26. That's over our denominator. So that's our denominator. So now we have what the top simplifies to. Now let's simplify the bottom. All right, so the bottom, we bring it out. We can't really do anything here. So let's see if we could top. Factor? No, we can't factor the top. What about the bottom? Can we factor the bottom? We totally can. We can factor that into x plus 7 and x plus 2. All right, so now we have what the top equals and what the bottom equals. So on the top, it simplified down into 8x plus 26. And on the, over x plus 7, x plus 2. And on the bottom, it simplified down into 4x plus 13 over x plus 7, x plus 2. All right, let's simplify this now. Yes, you can. Yep, you can. But let's say you don't like to do it that way. We know that this symbol just means division. So we have 8x plus 26 over x plus 2, x plus 7. And that's divided by 4x plus 13 over x plus 2, x plus 7. We keep change flip. After we keep change flip, let's see if they have anything in common diagonally. So here they do. And here they don't. So let's just write what we have left over. So what we have left over is 8x plus 26 over 4x plus 13. How do we know we're done? Let's see if we can factor anything. So on top, we can take something out of the top. We can take a 2 out. So if we take a 2 out, we're left with 4x plus 13. See what happened? So we can cancel those out now. And all we're left with is 2. Yep. After all of that, we're left with 2. I don't know. I think it's fun. All right. Simplifying with negative exponents. So negative exponents are not allowed. When you have a rational expression where some of the variables have negative exponents, or you write the expression using positive exponents, you're not allowed to have negative exponents. To make them positive, you flip the variable with the exponent, and then it becomes positive. So what does that all mean? Let's simplify. We have x to the power of negative 2 times y to the power of negative 2 all over 5x to the power of negative 1 plus 2y to the power of negative 1. So meaning we have to flip these. We're not allowed to have the negatives. That just, you're not allowed to. You'll learn why in college algebra. 6.3 in college algebra, you will learn it. So we have to flip them, and when we flip them, they become positive, or what we would say, they become rational. And we're just going to do the same thing to our denominator. Now, you only flip the variable that has the negative exponent. We don't flip the 5, so we keep it as 5. We're going to flip only the variable, so it becomes times 1 over x. Remember, don't flip the number, only flip the variable. So 2 times, and then we're going to flip the variable, 1 over y. Let's do this piece by piece now. Let's take it out piece by piece. So on the top, we can multiply. So on the top, we technically have 1 over x squared times 1 over y squared, which is 1 over x squared y squared. And on the bottom, we now have, let's simplify this, we have 5 over x plus 2 over y. So let's get the denominators to be the same, just multiply them together. So times y times x times x. So on top, we have 5y over xy plus 2x over xy. And so now we have 5y plus 2x over xy. So let's put it where it's supposed to be. On top, we now have 1 over x squared y squared. And on the bottom, we now have 5y plus 2x over xy. Let's switch the way this looks, because remember that just means division. So we have 1 over x squared y squared divided by 5y plus 2x over xy. We keep change flip. All right, let's look diagonally here. They have nothing in common. But what about here? They do share something. They share an x and a y. So we can cancel out one of the x's and then one of the y's. So what we're left with on top is just 1. And then on the bottom, we have xy times 5y plus 2x. That's it.